Finding the first derivative was fun. Finding the second derivative was even more fun. So obviously we want to find more and more and more derivatives, but have more and more fun. This is the idea of higher derivatives. So we can take generically a kth derivative for any positive integer k, and this is notation we use. For example, if k was 6, this says d to the 6 over dx to the 6th of f of x. That means we apply d dx 6 times. On the other hand, this doesn't say take the 6th power of f. The parentheses around the k means say take the kth derivative. Let's use this notation in an example. Suppose we were asked to find the fifth derivative of this function, 7x cubed plus 3x squared minus 4x plus 8. We just go one at a time. We find the first derivative. The first derivative of 7x cubed is 21x squared. The derivative of 3x squared is 6x. The derivative of minus 4x is minus 4. The derivative of 8 is just 0, so it doesn't show up at all. Then we take the derivative of this. To get the second derivative, we take the derivative of 21x squared plus 6x minus 4. The second derivative is then 42x plus 6. The minus 4 goes away. Then we take the derivative of this to get the third derivative. Here's our notation. We're going to use a little 3 there. We're going to put parentheses around it so we don't mean power. We mean take the third derivative. In this case, it means take the derivative of the second derivative. So the derivative of 42x plus 6 is just 42. And then to get the fourth derivative, we take the derivative of 42, but 42 is a constant, so the derivative is 0. And at that stage, the fifth derivative, well, it's the derivative of 0, which is 0. So you could actually figure out from here what the 75th derivative was. It would be 0. In particular, if you start with a polynomial and you take a derivative larger than the highest power, you're always going to get 0 back. These are higher derivatives. They get used a lot.